Okay, I want to introduce you now to the expectation theorems which come up in exercise 10c. We've learned already about expected value of x in exercise 10b and 10c. Now, what if we were to get something such as expected value of 3x, and what would we even need to use that for? Good question. I'll show you a practical example of why we would use something like that in a little while, but what I want to focus on first of all is how we would find something like the expected value of 3x. And we've got three theorems here. Expected value of ax, you take the a out the front and multiply it by the expected value of x. The expected value of ax plus b, you take the a out the front, multiply it by the expected value of x plus b. And remembering here that a and b are what's called constants or numbers. And expected value of two discrete random variables is the expected value of one of them plus the expected value of the other. We don't use that one very much, but I'll put that in there anyway. Alright, let's have a look at a practical example. Here's a discrete random variable, capital X, and here's its probability distribution. And we've got our x values and our probabilities. First thing we're going to find here is e of x, expected value of x, expected value of 3 of x then, and then expected value of 2x minus 4. So we'll find them one by one. First thing we're asked to find is expected value of x, and I've done that here. We've seen this formula before now. Here, the sum of the x values multiplied by the probabilities. And you can see there along the line here, I've multiplied each of the x values by their probabilities. So 1 times 0.25, 2 times 0.26, 3 times 0.14, and 4 times 0.35. Now I've gone through that quickly because we've seen that before. And the answer is 2.59. Okay, so that's the expected value of x. So I said nothing new there, we've seen that process before. Okay, so what about the expected value of 3x then? Let's look at that. Well, on that first slide there, I introduce you to the rule that says the expected value of a constant, a times x, in this case it's 3, is a times the expected value of x. So using that rule there, expected value of 3x equals 3 times the expected value of x. See how I've taken the 3, which is my a value, and put it out the front. Okay, so that will equal 3 times, now of course we just worked out what the expected value of x is. It's here, it's 2.59, so it's 3 times 2.59. That equals 7.77. About our next example here, okay, which is part C, which is E, so expected value of 2x minus 4. Now, on that first slide once again, let's go back to it. I referred to this rule here. Let's highlight it, that one there. Okay, so let's write that down. And the rule says that, the rule says the expected value of ax plus b equals a times the expected value of x plus b. Alright, so we've got expected value of 2x minus 4. So using that rule, we know that the a pops out the front, so it's 2 times the expected value of x plus b. Now, plus b here is our negative 4, so the negative 4 goes there. So that means we've got 2 multiplied by 2.59, which is the value for the expected value of x. Okay, we can bracket that, minus 4 equals 1.18. So there's our answers there of our two questions. Expected value of 3 of x, expected value of 2x minus 4. Utilising those two theorems, called expectation theorems, that one there, and also that one there. Okay, now let's put that to a practical use. Casey sells mobile phones. She receives a base salary of $200 per month and $15 for every mobile phone sold. The table shows the probability of a particular number of mobile phones, and we call it X, being sold per month. What would you expect the salary for Casey would, what would be the expected salary Casey would receive each month? All right, let's have a look at, let's find out a formula which will tell us where X is the number of mobile phones, what the salary would be. So let's just write that variable out, which is, I might just change pen colour here. Okay, so our variable is X. Okay, so it's $15 every mobile phone sold, so 15x. Okay, so we could call say S for salary here. Okay, the salary will be $15 multiplied by the number of mobile phones sold plus $200. So if we inserted X there for the number of mobile phones, we could work out the salary per month. Okay, 15 times X plus 200. All right. Now we have to find out the expected salary received each month based on these probabilities. Okay, so we're not actually looking for expected value of X this time. Okay, we're not looking for the expected number of mobile phones. We're actually looking for the expected salary connected to selling those mobile phones. If we wanted to find the expected number of mobile phones sold, we would just multiply 50 by 0.48 and so on and add them together. But we're actually after the salary. So instead of E there and an X in brackets, expected value of X, it's going to be expected value of the salary, 15x plus 200. Now this is where, to calculate this, we can use our expectation theorems that we just used before, and we can pop the 15 out the front, multiply by expected value of X plus 200. Just going back a few slides, I'm utilising here this rule here. Put the blue ticks next to it. That's the rule we're using to find expected value of 15x plus 200. We put the 15 out the front of the expected value of X plus the 200. Now, of course, to work that out, we do have to find out the expected value of X first. Okay, so let's go over here and do it. Expected value of X equals 50 times 0.48 plus 100 times 0.32 plus 150 times 0.1 plus 200 times 0.06 plus 250 times 0.04. Now, it's sometimes a good idea, just to make things nice and clear, to bracket those, like so. Let's work that out. Right, if we calculate that, it works out as a nice even number. It's 93. So we can now use that figure there, back over here, to find out that salary. And just to give myself some room, I might just clear that off for the moment. Now that we've found E of X, just to give ourselves some more room here. Now it's 93. Okay, so it's going to be 15 times 93 plus 200. So the expected salary is going to be $1,595. So that's a practical example where you need to use the one of the expectation theorems. When you're not finding the basic expected value of X, you're finding the expected value of something such as 15x plus 200. It's quite simple. If you use that theorem, you still got to find the expected value of X, but if you place in that theorem, you can get the answer quite easily. Okay, so what I'd like you to do now, if you haven't already, is to exercise 10C, numbers 17 to 19.